beauty of nature and life itself is created by rhythm. It is the way of things for as long as we have known life. We are reminded of that by the world around us, with the different patterns seen across nature, like how animals move in synchronization, and even by our own bodies, with the way our heart beats and the way we breathe. Everything functions on a certain rhythm we may or may not know about. The rhythms of nature are just like a heartbeat. They take care of themselves and run in the background. Others are similar to breathing, a default pattern that works on its own. In Ian Stewart's Rhythm of Life, we will learn how mathematics plays a great role in creating the rhythms we are surrounded by.
Analysis. The gaits analysis is a branch of mathematics that studies patterns of movements and motions. Before high-speed photography, it was impossible to find out how an animal's legs move while it ran or galloped, until Edweard Muybridge photographed the different phases of the horse's gait, therefore pioneering the study. Fun fact, he invented zoetrope, a device that displayed moving pictures, so he also invented movies. It doesn't only study animals though. It's generally about locomotion, in the way you walk or run after a trip when you're running late, or when you just want to go home because you're really tired. Well, that's it.
The oscillation concepts. Oscillation in its simplest terms is a unit wherein a natural dynamic causes it to repeat the same cycle of behavior over and over again. Think of the wheels around a bike, a car, or even a pedicab. The wheels cannot just detach themselves since they're secured in place, but the simplest option is to find a series of motion that works to repeat over and over again. However, any oscillations arise out of steady states. As conditions change, a system that has a steady state may lose it and begin to wobble periodically. I think we're done here. Let's move on to the next.
Hopf Bifurcation. In 1942, Eberhard Hopf proved that the simplified system wobbles, then so does the original system. Bifurcation described the mental image of what happens when periodic oscillation grow out from the original steady state. Drop a pebble into water and see how it ripples from its center. It starts small before gradually increasing its size. Like the clarinet, when you blow it softly, it sounds soft. When you blow out loud, it sounds loud.
The symmetry breaking theory explains that animals can naturally change gait without a gearbox. Think of a horse that has different gaits. It can walk, trot, and gallop, entirely different movements from each other. When an animal or a person moves, there's a less symmetry. For example, you have two legs, that's symmetry, but when you walk or run, you don't move both legs at the same time because you'll fall over if you do. Then another example of breaking symmetry would be the six-legged cockroach. The middle leg on the side moves in the face with the front and back legs on the other side, and then the other three legs move together.
Locomotion and synchronization are nature's functions and are emphasized by mathematics. There is mathematical unity in life, such as animals and people, and general mathematical concepts can be applied to biology, science, and nature to help us understand the way of things. Now you can say that mathematics
Really exists everywhere.
Mathematics eliminates
The aspects of nature we rarely acknowledge, but still teaches us
the rhythm of life.
the rhythm of life.
The rhythm of life.
the rhythm of life.
Thanks, everyone!